Now our mode to determine I naught with the help of Thevenin's theorem. So how can we determine? First of all, we assume that is X and here Y terminal. Okay, and this 2 kilo ohm behave as a load resistance. That is 2 kilo ohm behave as a load resistance. So first of all this whole circuit converted into Thevenin's equivalent VTH and RTH corresponding to XY terminal. After that, load resistance, that 2 kilo ohm added here and determine I naught. Okay, very simple. So first of all, our mode to determine VTH. VTH means open circuit corresponding to these two terminals. So if this one is open, apply KVL in this loop, then we got I1. Okay, and put this value Vx, this will equal to 4 into I1, so that is 4 volt. Apply KVL in this loop, then we got minus to plus, and apply KVL in this loop, we got I2 is 0.5 milliampere. Now after that, apply KVL in this loop, then we got V of OC, that is 2 volt. Now next target is our mode to determine RTH. So how can we determine RTH? This I know that all independent source reduced to be 0, that is voltage source, that is reduced, that means open short circuit. Okay, 0 voltage means short circuit. Okay, after that, this XY terminal, you can assume 1 volt voltage source or 1 ampere current source, because of that is dependent source available. That's why our mode to determine RTH. So we have, if you assume 1 volt voltage source, then current is I. So 1 volt is equal to I into RTH. So what about RTH? RTH is 1 by I. Basically our mode to determine 1 by I. Then that is RTH. Clear? So how can we determine? I apply KCL at that node. I this will equal to I1 plus I2. Okay, if this one is 0 volt, then this one is a Vx. Okay, so I this equal to I1 plus I2. I1 is Vx minus 0 divided by 8 and I2 is Vx minus 0 divided by 4. Put this value and solve. We got Vx in the terms of I, 8I divided by 3. Okay. Now next target is apply KCL at that node. I3 plus I4 this is equal to I. I3 is written as 0 minus Vy divided by 4 and I4 is written as 0 minus Vy minus 2 plus 2 Vx divided by 12. This is equal to I. Okay. So finally after solving like this one, then we got this one. And next one, Vx minus Vy, this is equal to plus 1 volt. So Vy is written as Vx minus 1. If this value Vy put here, then we got like this one. Okay, and Vx value put here, then we got I, or you can say the 1 by I, that is 4.63 kilo ohm, that is RTH. After that, these value and this value put here, that is Thevenin's equivalent corresponding to XY terminal, that is 2 volt, here 4.33 kilo ohm. Okay, and that is load resistance. After that, I naught is VTH divided by sum of these two resistance, then we got 0.316 milliampere is the right answer. Make it.